So let's look at a reaction that we can use if we want to make an ester. So let's start with a acid chloride molecule. And if we treat that acid chloride with, let's say, sodium methoxide, okay, what's going to happen is that we're going to have an acyl substitution. So this piece right here, there's the acyl group. And what we're going to do is replace that piece right there, the chlorine, with this piece right there. And we would get something that looks like this. We would generate our ester. And then our chloride would be floating around. So what we've done is an acyl substitution. We've replaced that with this piece. So you can see we've gone from an acid chloride to an ester. And the mechanism for this is we will see that our sodium methoxide, we'll use that version right there, and we will have a nucleophilic addition. And this reaction is not reversible. We'll talk about why that is in a moment. But this is our nucleophilic addition step. So that will give us our tetrahedral intermediate. And then we will have our nucleophile elimination. So this lone pair right here will collapse back down, and then it will kick off the chlorine as that chlorine is a leaving group. And then we would have our ester, and our chloride would be floating around, just like that. Now, the question is, why is this reaction not reversible? Well, it has to do with the stability of the attacking species and the stability of the leaving group. So if we put this in general terms, if I have right there. So what I'm representing is any carboxylic acid derivative that has a leaving group right here. And if we treat that with any type of nucleophile here, okay, what's going to happen here? And this marker's fading. Let's see if we can get, no, it's not going to do it, is it? Oh, not chlorine, Rl. So that will now be negatively charged like so. Okay. So when we take a look at this generic reaction here, these acyl substitutions right here can be reversible when the stability of the attacking species and the leaving group, their stabilities are relatively the same. If we have a situation where the stability of the leaving group right here is more stable by a significant amount than the stability of the attacking species, then it's no longer going to be an equilibrium process, but it's going to be an irreversible process, and it's going to favor the products. But in contrast, if the attacking species is significantly more stable than the leaving group, then we're going to have something like this, and the reaction does not proceed. So when we see this reaction here in the middle, what we're comparing is the stability of this methoxide and the stability of this chloride. And this reaction is irreversible because the chloride is way more stable than the methoxide. So this reaction is favored to the right because of the stability of that leaving group. But if you compare something a little bit different, what if I had this product right here? Okay. What if I had that I keep doing the R's. pH, there we go. What if I had that and I treated that with sodium chloride? Would we get this as my product? Would I get an acid chloride? Because remember, sodium chloride is an ionic species. So sodium is just a spectator ion, and that chloride is going to be negatively charged. Does this reaction work? Well, we have to take a look at the stabilities. So I'll put the chloride right here. Okay. And then what would have left? What's the leaving group? That right there would be my leaving group. CH3 minus. So now we see that, hey, the chloride now is on the reactant side, and we just learned that this is going to be way more stable than this. So that means equilibrium is going to favor this way. So that means that this reaction does not happen. So to go from an ester to an acid chloride is not thermodynamically favorable, and it won't happen. The reaction does not occur. And so we can draw a little imagery here to like, okay, which carboxylic acids can react and which ones cannot. And I'm going to compare it to rungs on a ladder. So I'm going to clear out this board and draw that, and we'll take a look at this analogy. So here I have my ladder with 4 rungs on it. And when we talk about a ladder, generally speaking, it is easier to climb down a ladder than it is to climb up a ladder. So what we have here, for each of these rungs, we have different types of carboxylic acid derivatives. We have our acid chloride at the very top rung, and then we have an acid anhydride, esters, carboxylic acids, and amides. And so what this analogy is saying is that if you're on a top rung, it's relatively easy to go down to the second rung. And so what that's saying is that, hey, we can convert acid chlorides into the groups that are below it. So we could take acid chlorides and convert it into each one of these because it's lower on the ladder. But going up, so if we have an ester and we want to convert that ester to an acid chloride, that is energetically not favorable because we're starting at a lower rung and then we want to go up. That's just energetically not favorable here. So what we can say here is as we go down the rung, that's energetically favorable. And if we go up the rung, that's energetically not favorable. And another thing that we could take a look at is if we could do just another column here on this side. These are the carboxylic acid derivatives. But what's the leaving group on these derivatives here? That's the leaving group. So that would give us a chloride. Okay? And then this right here would be the leaving group, and that would give us something that looks like this. And then that would, for the carboxylic acid, that would be the leaving group right there. Or that guy right there. And then that would be the leaving group right there. Okay. Now, what can we say about these leaving groups in terms of energy? We can see that as we go up this way, we are increasing instability. So this is the most stable. This is the least stable of this list right here. So that's an analogy to help you remember which transformations can and cannot occur. But I say that in general terms because you will encounter some situations where there's an exception. But generally speaking, this is the idea that you want to have in your head.